Alright, let's look at the homework 2.8, problem number 3. Right? So we want to find the derivative of this rational function using the definition of derivative. Right? So let's do that. Alright, so we want to find g prime of u. Right? So this is going to be equal to, right? So we have a limit as h approaches 0. Right? So I'm going to write down the definition. So we would want to find g of u plus h minus g of u all over h. Right? So let's do that. So we have a limit as h approaches 0. So we'll take care of the limit later. Right? So using the function notation, we can write g of u plus h as, all right, so every time you see u, we're going to put u plus h. So we have a u plus h plus 1 over 7u plus h. I'm going to go ahead and multiply out. So 7u plus h would be 7u plus 7h. Then you have a minus 1, right? So that's g of u plus h minus g of u is just exactly the original function. So you have a u plus 1 over 7u minus 1. Then all over h, right? So we have that. All right, then we're going to try to combine the two quotients in the numerator, right, by finding the common denominator, right? So let's do that. All right, so this is going to be equal to, we're going to leave the limit alone. H approaches 0. All right, then we have, all right, common denominator is going to be just the product of those two denominators. So you just multiply those guys together. So you have a 7u plus 7h minus 1 times 7u minus 1. All right. Then we have to multiply the numerator by 7u minus 1. So I'm going to distribute the 7u. So you have a 7u squared. All right, 7u times h would be 7u(h). 7u times 1 is just a 7u. Right? Then distribute negative 1. So negative u, then negative h, and negative 1. Right, so we have a minus sign here. Right, I guess I have to extend this here. Right, then we'd have to multiply the other numerator by this denominator in the first quotient. So I'm going to distribute the 7u. So you have a 7u squared, 7u, and distribute 7h. So you have a 7u(h), and then plus 7h, and then distribute the negative 1, so it's a negative u minus 1. Right? So let's clean it up. You have 7u squared here minus 7u squared. Right? 7u(h) minus 7u(h). 7u minus 7u. Right? And then there's a negative u minus negative u. Right? Then you have negative 1 minus negative 1. Right? So what's left is there are actually a couple of terms left over. So you have a negative h right here. Right? Then you have actually negative 7h. So don't forget the negative sign here. So negative 7h. So that'll be negative 8h. Right? So if you combine those guys together, you have a negative 8h. And those are the only thing that's left over. So we can cancel h on the bottom, h on top. So that's just a common factor. All right, so what you get is, if you clean it up, you have a limit as h approaches 0. All right, on top, you have a negative 8. And on the bottom, we have a 7u plus 7h minus 1 times 7u minus 1, right? So as h approaches 0, 7h is going to approach 0. So this guy basically disappears. Right, so what's left is going to be, you have a negative sign and 8 on top, and then on the bottom, you have a 7u minus 1 times itself, so you have a quantity 7 minus 1 squared. Right, let's type it in. Right, we got negative 8 over quantity 7u minus 1 squared. Right, let's check the answer. Alright, I came back and looks like we got the derivative correctly. Right? State the domain of the function. Right? So you can see that this is a rational function, so we don't want u to be, the denominator to be 0. So if you set the 7u minus 1 equal to 0, or actually, we don't want that to be 0. So domain would be 7u minus 1. We don't want that to be 0, right? So which means that, let's see, add 1 to both sides. So you have a 7u cannot be equal to 1. And then we can just divide through by 7 to isolate u. So we cannot have u equals 1 over 7, right? So all real numbers except for 1 over 7, right? So we just have to write it in the interval notation. So we have negative infinity, right, to 1 over 7. Then we're going to skip 1 over 7. So we go to set notation here and the union. And then we can go from 1 over 7 to positive infinity. All right, so we have that. And the domain of its derivative is actually exactly the same. So I'm going to just copy that and then put it in there and see if it works. All right, so we have that. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.